Okay, we're going to look at straight lines which are called perpendicular bisectors. A perpendicular bisector is a straight line that cuts another straight line at a right angle and also cuts it in the middle. So if that was the line AB, then the line CD would be a perpendicular bisector to the line AB. If we've got a triangle, let's call this triangle ABC. Any triangle has got three perpendicular bisectors, so the perpendicular bisector of AC would look something like this. So it cuts in the middle and at a right angle. The perpendicular bisector of BC is something like this, cuts in the middle and at a right angle. And the perpendicular bisector of AB would look a bit like that, cutting in the middle and at a right angle. Since a perpendicular bisector is a straight line, there's two things which we need, which is a point that lies on the line and also the gradient of the perpendicular bisector. Once we get them, we then put it into y minus b equals m bracket x minus a. So let's try a few questions related to perpendicular bisectors. Okay, A is the point 1, 3. And B is the point 5 minus 7. And we're going to find the equation of the perpendicular bisector of AB. So there's a representation of the line AB. Now the perpendicular bisector is going to cut in the middle, and it's also going to cut at a right angle. So to find the equation of the perpendicular bisector, which is this line highlighted here, it's a straight line, so we need point gradient. So the first thing that I'm going to do is to find the point. Now, since it's a point of bisection, that's the midpoint. So the midpoint is an average of x and the y coordinates. So that's x1 plus x2 over 2, y1 plus y2 over 2. And that's 1 plus 5 over 2. And 3 minus 7 over 2. 1 plus 5 is 6 over 2 is 3. 3 minus 7 is minus 4 over 2 is minus 2. So now I've got the point, which is 3 minus 2. Now what I'm going to do next is find the gradient of AB. And from then look at how to find the gradient of the perpendicular line, which is the perpendicular bisector, using some knowledge that I've already acquired in a straight line. So the gradient of AB is going to be minus 7 minus 3 over 5 minus 1. Minus 7 minus 3 is minus 10. Minus 10 over 5 minus 1 is 4, and that will simplify down to minus 5 over 2. Now, since the perpendicular bisector is a perpendicular line, I then invoke m1, m2 equals minus 1, and that's the flip and invert the fraction. So minus 5 over 2, flip that over, change its sign, and I get 2/5. So I've got a gradient of 2/5, I've got the point 3 minus 2, and I now sub that into y minus b equals m bracket x minus a. So that will be y minus minus 2 equals 2/5 bracket x minus 3. That's y plus 2 equals 2/5 bracket x minus 3. Multiply through with 5 to get rid of the 5 on the bottom. 5y plus 10 equals 2 bracket x minus 3. 5y plus 10 is equal to 2x minus 6. Bring that 10 across, change its sign. 5y equals 2x minus 16. And that's the equation of the perpendicular bisector. Okay, let's try a second example. Find the equation of the perpendicular bisector of each side of the triangle with vertices D minus 4, 2, A 9, 2, and V 7, 1. Okay, so let's sketch that out. So there's a point minus 4, 2, which is D. and there's a point 9, 2, which we're calling it A, and 7, 1 might be around here, and that's the point V. Okay, so let's first of all find the perpendicular bisector of AD. So the perpendicular bisector is a straight line which cuts in the middle and cuts at a right angle. So to find the equation of a perpendicular bisector, we need point and gradient. So let's first of all find the point, that's the midpoint, and that's an average of the x and the y coordinates. So that would be -4 plus 9 over 2, and 2 plus 2 over 2. -4 plus 9 is 5. 5 over 2, well, let's just leave that as 5 over 2. 2 plus 2 is 4. 4 over 2 is 2. So the point then is given by 5 over 2, 2. Let's now find the gradient by first of all finding the gradient of dA. So that's going to be y2 minus y1, 2 minus 2, over x2 minus x1, 9 minus 4. That will give me 0 over 13, which is equal to 0. Now that's then a horizontal line. Now perpendicular to that then, and that upside down T denotes perpendicular line, and the gradient of it must be a vertical line, and a vertical line has a undefined, or if you like, infinite gradient. Now if it's an undefined gradient, that means it's a vertical line. If it's a vertical line, it's got the equation x equals, and I just check the x coordinate in which it passes through, which is 5 over 2. So x equals 5 over 2 is the equation of the perpendicular bisector. Let's now find the perpendicular bisector of dV. So the diagram's just going to be a bit busy, but cuts at a right angle and in the middle. So let's go after the midpoint this time. So average of the x and the y coordinates, that will be -4 plus 7 over 2, and 2 plus 1 over 2. -4 plus 7 is 3. 3 over 2, I can just leave that as 3 over 2 then. 2 plus 1 is 3. 3 over 2, and I'll leave that as 3 over 2, so that's the midpoint. Let's now find the gradient of dV, and then have a think about the gradient of line which is perpendicular. So that would be 1 minus 2 over 7 minus 4, and that's -1 over 11. We're looking for the gradient of line which is perpendicular, so m1, m2 equals -1. Flip -1 over 11 over and change its sign, and that will give me 11 over 1, which is a gradient of 11. Okay, and let's put that into y minus b equals m bracket x minus a. That's y minus 3 over 2 is equal to 11 bracket x minus 3 over 2. Let's eliminate the denominator of 2 by multiplying it through by 2. So that will be 2y minus 3 is equal to 22 lots of x minus 3 over 2. That's 2y minus 3 is equal to 22x minus 66 over 2. 2y minus 3 is equal to 22x minus 33. Put the minus 3 across and change its sign, and that will be 2y equals 22x minus 29. Okay, we're now going to find the perpendicular bisector finally of the third line of the triangle AV. So the perpendicular bisector again cuts in the middle and at a right angle, so let's first of all find the midpoint of AV. Okay, average of the x coordinates, 9 plus 7 over 2, average of the y coordinates, 1 plus 2 over 2. 9 plus 7 is 16 over 2 is 8, 1 plus 2 is 3, 3 over 2 is just 3 over 2. So that's the point that lies on the perpendicular bisector. Now let's find the gradient. So first of all, let's find the gradient of VA, and that will be 2 minus 1 over 9 minus 7, which is 1 over 2. It's then m1, m2 equals minus 1. So the gradient of line which is perpendicular, 1 over 2, flip it over, change its sign, will be minus 2 over 1, which is just minus 2. I've now got the point and the gradient, and it's y minus b equals m bracket x minus a. Y minus 3 over 2 is equal to minus 2 bracket x minus a. Let's multiply through with the 2 to get rid of that. 2y minus 3 equals minus 2x plus 16. 2y equals minus 2x, bring that across, change its sign, plus 19, and that's the equation of the perpendicular bisector.